All right, let's look at number 13 from the sample test. So for f of x equals x cubed minus x times x minus 1 cubed times x plus 2, we want the zeros and the multiplicity. Okay, so if I set each of these equal to 0, x cubed equals 0, x minus 1 cubed equals 0, x plus 2 equals 0, then here I'm going to get x equals 0 3 times because this is like x times x times x, right? So that would be x equals 0, x equals 0, x equals 0. So we call that a multiplicity of 3. Same thing right here. This would be like x minus 1 times x minus 1 times x minus 1. So that means I'm going to get x equals 1 as an answer 3 times. So that's a multiplicity of 3. This one, there's only one of these, so I would only get one answer of -2, and that's a multiplicity of 1. So remember why the multiplicity is important, because if you have a single root, a multiplicity of 1, when you graph that x-intercept, your graph is going to go straight through that point. If you have a double root or a multiplicity of 2, your graph is going to turn on that point. And then if you have a triple root, a multiplicity of 3, then your graph is going to slide through that point. So we come down to number 14 and it asks us to sketch this graph. So first off, let's figure out what the leading coefficient test tells us about its end behavior. So first off, this is a degree of 3. I know that's a little hidden, but see how this is x to the second, so that's x squared, and then times x to the first. So that would be x to the third. So this has a degree of 3. Also, my leading coefficient is a positive 1. So I know the leading coefficient tells me how it ends. So I know it's going to end going up. And since it's odd, it starts and stops in opposite directions. So I know that it's going to start going down. So it's going to start down and it's going to stop up. Now, they didn't say here how does it start and how does it stop, because remember there are several different ways you could write that. If you're looking at the number line, the negative numbers are over here. So this is x going off to negative infinity. And then the positive numbers are over here. This is x going off to positive infinity. So when they say x approaches negative infinity, that's the same thing as saying how does it start. And as it goes to a positive infinity, that's like saying how does it stop. All right, so we knew that it started down and it stopped up and that it's a degree of 3, so it should turn 2 times. So this is what its shape would look like. Additionally, sometimes instead of saying that the behavior is that it goes down, when something goes down, 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 it goes to negative infinity. Or when something goes up, 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 it goes to positive infinity. So that would be another way we could express that. Okay, so we know we're going to start down and end up, and we know that, let's find our x-intercepts with their multiplicity here. We've got x plus 3 squared times x minus 2. Okay, so x plus 3 squared, if we solve that, that's like x plus 3 times x plus 3. So that's going to be x equals -3, and we get that twice, so that's a multiplicity of 2. And remember that at a double root, at a multiplicity of 2, your graph is going to turn at that point. And then x minus 2 equals 0, that would be x equals 2. I only got that answer once. That's a multiplicity of 1. And remember, at a multiplicity of 1, I just go straight through my graph. All right, so I'm going to start down. And as I approach my first root at -3, since that's a double root, I'm going to turn on that point. And then when I come back up to go through the positive 2, I'm going to go straight through because that was a single root there. Now, I didn't go ahead and find like the y-intercept or plot any points here because this is just a sketch. I don't have to worry about like how low this goes or anything like that. But they did ask me the last thing here to find the y-intercept. So that's where x is equal to 0. So if I put 0 in the place of x in my equation, I'm going to get -18. So if we wanted to be more precise here, you know, we could, this is going to be like way down here at -18. We would have to like rescale this axis. But again, we're not worried. It's a sketch. We're not drawing it perfectly. All right, then for number 15, it said use the graph to write the equation of a polynomial function of least degree. And then for number 16, you're also writing the polynomial function. I actually think 16 is a little easier than 15. So let's do 16 first, and then we'll go back to 15 because they're two identical problems, but it's just the way that it's asked is a little different. So 16, they told me I'm going to have a degree of 3, and they told me that these are going to be my solutions, -5, -2, and +1. Okay, so x equals -5, x equals -2, x equals +1. If it's a degree of 3 and those are my three answers, they're all going to have to be single roots because I don't have room for a multiplicity of anything else. All right, so this is how I write it as a solution. To write it in its factor form, all I need is for it to be equal to 0. So if this x was going to equal 0 instead of -5, then I would need to add 5 to both sides. So I would have x plus 5 is equal to 0, or it's also just the opposite of that number. Normally we're doing the reverse, right? Like normally we're taking this and solving it to get this. So we're just going backwards. So same thing here, x equals -2 would be x plus 2, and x equals 1 would be x minus 1. All right, so now that we've got all of our factors, we're going to string them all together. And the only thing we need to do is find our leading coefficient. All right, that's why they gave me this extra piece of information right here, 0, 6, because if I put 0 in for each of my x's, then I know that my y value is going to be 6, and the only unknown would be a, and I'd be able to solve for it. So that's going to be 5 times 2 times -1, or -10. Divide both sides by -10, and I'll end up with -3/5 for my a value. All right, so if I put -3/5 right there for that a value, that's going to be -3/5 times x plus 5 times x plus 2 times x minus 1, and that's where we got this final answer right here. So in number 15, they're asking me to do the same thing. It's just they don't tell me what the x-intercepts are like they did in 16. They give me the graph. And I can just look at the graph, and since I know that a solution, root, x-intercept, 0 are all the same thing, then I know that I'm going to have a solution at x equals -2. So right there, x equals -2. I'm going to have a solution at +1 and at +3. So right there, +1 and +3. And as we said a moment ago, these are all in their solution form. If you wanted to write it as a factor, you just set it equal to 0. It's just the opposite of that. And so since each of these went straight through on the graph, they each have a multiplicity of 1. All right, so we're going to start the same way where we're going to write this as a factor and write this as a factor and write this as a factor and then string all those factors together. The only thing we don't know is our leading coefficient, and so I need a point to plug in. So they didn't give me that point, but I can come over here to the graph and pick any point that I want that's not an x-intercept because I've already used those. So I thought 0, 3, the y-intercept, would be an easy point to use. So if you'll notice, if I put 0 in for each of my x values, I know the answer I get is going to be 3, and the only unknown then would be a that I could solve for. All right, so we're going to get 2 times -1 times -3, so that's going to be a +6 times a is equal to 3. Divide both sides by 6, and we'll get a is 3/6, or 1/2. So let's come put that 1/2 right here, and that would be 1/2 times x plus 2 times x minus 1 times x minus 3. And so that's what you can see is our final answer down here. So again, the exact same thing in 15 and 16. It's just that in 16, they gave me my x-intercepts. In 15, I had to pull them off of the graph. And then they also gave me a point to use, the y-intercept, whereas in this one, I had to go pull that point off myself. But once I had that information, they had me do the exact same thing with it in both of those problems. All right, so let's look at number 17. So for number 17, we get into our synthetic division. Remember that you can divide by synthetic division anytime you're in the form of x minus k. So you can see right here that the k value is going to be 5. So again, it's just like x minus 5 is the factor form, x equals 5 is the solution form. So k is the solution, and that solution k is what goes in our little box. And then across the top here are our coefficients. So we've got 1, -15, +75, -125. All right, so for synthetic division, that first term comes straight down. So then 1 times 5 goes in the next column. And then combine, -15 and 5 is -10. Negative 10 times 5 goes in the next column, negative 50, and then combine. So 75 minus 50 is 25. 25 gets multiplied by 5 and goes in the next column, and negative 125 and 125 is 0. So to write my answer, remember that this first term right here is always going to be one less than the original. So the original was x cubed, so this is going to start with x squared. So that would be 1x squared minus 10x to the first plus my constant 25 that doesn't have an x, and then this would be my remainder. Now, if we get a remainder of theorem, if we get a remainder of 0 from the remainder theorem, we know that that means that what we were dividing by is a factor. So we were dividing by x minus 5, so that means it is a factor. And we could write that factorization. So we could say what we started with, this cubic right here, is equal to what we divided by times the answer that we got. Here's a simpler version of that. If you divide 6 into 30 and get 5, then you could factor 30 by saying it's 6 times 5, what I divided by times the answer I got. So the same thing here, this can be factored down to what I divided by times the answer that I got. Now, they didn't ask me to finish solving this, but I definitely could solve this quadratic right here if they asked me to. They just asked me to solve it to get the quadratic. All right, then for number 18, all right, so same kind of problem. You can see that x minus k is the opposite of that number. K is a negative 3, and that's the same thing that goes in my box here. Coefficients across the top, so the 3 comes straight down. 3 times negative 3 is negative 9. Negative 2 and negative 9 is negative 11 times negative 3 is positive 33. 33 and 1 is 34 times negative 3 is negative 102. Negative 102 and 4 is negative 106. So again, this starts with, it's always going to be one less than the original. So the original was a cubic, so this is going to start with x squared. So 3x squared minus 11x plus 34. And then the negative 106 is our remainder. And so because we didn't get a remainder of 0, then that means what we were dividing by is not a factor. Now, another way that we can write this remainder here is that I can write it as a fraction where the remainder is my numerator and what I was dividing by, that x plus 3 right there, that's my denominator. So sometimes they'll tell us to give our answer in a fraction form. So I just need to be able to write it either way that they ask me to. All right, then for number 19, same idea, but the only thing with number 19 is just a reminder that if you skip any terms, you have to fill it in with a 0 placeholder. So what I mean by that is, see how this went from x to the third to x to the second, and then there was no x term. It went straight to the constant term that doesn't have an x with it, or it's x to the 0. So they skipped from x to the second to no x, or x to the 0. So that means they skipped x to the first. So I have to put a 0 placeholder in for that. All right, so again, the opposite of this number, negative 1, would be positive 1. That's going to be my k value because, again, that's its solution form. And then I'm going to put my coefficients across the top, being sure to put in that 0 placeholder. All right, so our 2 is going to come straight down. All right, so then 2 times 1 is going to give us 2. Negative 4 and 2 combined to be negative 2. Negative 2 times 1 gives us negative 2. 0 and negative 2 combined to be negative 2. And then negative 2 times 1 gives us negative 2. And 5 minus 2 gives us positive 3. So remember that this is always one less. All right, so that means that we're started with x to the third, so that this is x to the second, x to the first, no x, and then this last term is our remainder. So because we didn't get a remainder of 0, that means what we were dividing by, x minus 1, is not a factor. And we also could write that remainder as a fraction, so that would be 3 over what we were dividing by, which was the x minus 1.